Hi, this is Mr. Marcados. In today's lesson, we will be connecting f, its first derivative f prime, and its second derivative f double prime graphically. A lot of the work we've done the last 2 weeks falls under the concept of properties of curves. What can we use the first and second derivative to tell us about our original function f? We use the first derivative to tell us information about where our original function is increasing or decreasing, where it has turning points, relative maxes, and relative mins. We've used f double prime to find out where the original function f has an inflection point, or where or on what intervals the graph is concave up or concave down. We are going to continue doing the same exact thing today. The only thing that's changing is I am no longer going to be doing this analytically or algebraically. I am going to figure out these behaviors and characteristics from the graphs of the first and second derivative. So what we'll be doing today is using our knowledge about what information f and f double prime can provide us about the graph of y equals f of x, we can also connect their graphs. So this first question has pretty much everything that we could possibly be asked if you were shown the graph of the derivative of f prime. So number one, the graph of f prime, the derivative of f is shown below on the interval from -6 up to 8 inclusive of the endpoints, and has horizontal tangents at -3. Maybe we'll mark those off. -1, 2, and 5. Remember, I don't care what graph you're talking about. If a graph has a horizontal tangent at a particular x value, we know that that point must be a turning point. That is what happens when you have a horizontal tangent. The graph has a turning point. Okay, so using this graph, and we have to reiterate the fact that you are looking at f prime. This is not the graph of f of x. It is the graph of f prime. We're going to answer a bunch of different questions. So part A, on what intervals is the function f increasing? Justify your answer. Again, we're being asked about f. We're not being asked about f prime, but we know that f prime can give us information about f. So we learned last week that a function f will be increasing when its derivative is positive. You are looking at the graph of the derivative. When would this graph have positive values or positive y values? We're talking about the function itself. The y values on this graph will be positive when the graph is above the x-axis, and we can highlight those pieces. So this sliver here from -6 to -5, and then this chunk here from -3 to +7. Those are the intervals where the derivative is positive. Those must be the intervals where the function f is increasing. So we're going to, and the reason and answer we're going to give is not changing from last week. I am just finding these intervals in a different way, in a visual way. I'm not doing it analytically. So I would say that f is INC increasing on, so we give the intervals. The first blue piece is -6 to -5. We got a union, and then from 3 to +7, I have to give a reason. It's the same reason I've been giving for the last 2 weeks. It's because f prime of x, the derivative of f, is positive or is greater than 0 on these intervals. There's nothing else we need to write. I am not changing my reasoning. My reasoning has stayed the same. The only thing that's happening is how I am determining those intervals are happening graphically. Similar question in B, on what intervals is f decreasing? Justify your answer. Well, decreasing, we know that the function has to be less than 0. The derivative, must be less than 0. You're looking at the derivative. Its graph. When is this graph have y values that are less than 0? When the graph is below the x-axis, and there are a couple of different places. Note that at -1, and I tried to not highlight that x value, the graph is not negative. It does not produce a negative y value there. The value of the derivative there would be 0. 0 is not a negative number, so we would not include that value in our intervals. It's a small but important thing that can cause a whole loss of point on a free response question. So I'm going to say, my cookie cutter responses here. F is decreasing on, so that would be from -6 over to -1. I'm going to stop at -1 in union, but I'm going to pick up at -1. So you kind of think of this as unioning around -1. And I have to go up to 3, union again, and then it's that last piece at the end from 7 to 8. I give a reason because f prime of x, the derivative, which is the graph you're looking at, is negative on these intervals. It's the same reason as last week, same reason I may have given earlier this week. It's because the derivative is negative. Okay, next thing. C, determine the x-coordinates of the relative extrema of f and classify each as a relative minimum, relative maximum, or neither. Justify your answer. That's pretty big amount of work. We know that a function will have relative extrema, which are turning points on your graph, when the derivative is 0 or undefined. This might seem a little tricky to think about, but this graph of f prime is completely defined between -6 and -8. So this function is the derivative that I'm looking at. It's never undefined. However, it is 0 in a couple of places. So where does f have relative extrema? It has relative extrema actually at the x-intercepts of f prime, because those are the places where f prime of x gives me 0. So I'm going to say f has relative REL period extrema at x equals, now I'm going to list them, so -5, -1, +3, and 7, because what happened at these x values? The derivative f prime of x equals 0 at these values of x. Okay, so cool beans. Now, the other thing we were able to do, besides just find where the turning points on the graph of f would be, is we were able to use the first derivative test to classify these places as relative mins, relative maxes, or neither. Let's start with mins, I guess. We know that when we analyze the derivative and we're looking for relative mins, the signs need to change in a particular way. One thing you can do to help you, although I would kind of call this like training wheels in a sense here, is you could create a sign diagram for f prime if you'd like, using the graph in front of you, which is not very hard, and so it's not a terrible thing to do because it's not going to take me very long. But now I have to put all the critical numbers there, right? So, and this shouldn't be 7, this should be 8, right? Going to the right end point of the domain. So -5, -1, 3, and 7. I know this is pretty tiny. But right now what I can do is say, okay, between -6 and -5, is f prime of x positive or negative? It's positive because the graph's above the x-axis, so I could put a plus there. Between -5 and -1, the graph is below the x-axis, so f prime of x is negative. From -1 to +3, actually the graph is still below the x-axis, and so it's still negative. The signs do not need to alternate. It really depends on the function's nature. And between 3 and 7 here, right, the graph is above the x-axis, so it would be a positive there. And then between 7 and 8, it would be negative again. So if I'm looking for, let's say, relative mins, I need the signs to change on the first derivative from negative to positive. That actually only happens one place here. It happens right here. This means that x equals 3 is a relative min of the function f. So, again, my reasoning does not change. It's just that, unfortunately, I'm changing the way I'm obtaining that information. So I'm going to say f has a, and nobody likes to write this, a relative min at x equals 3 because f prime of x changes sign. How does it change sign? I have to be specific. Changes sign from, it's going from negative, so I'm going to write neg period, to positive pos period at x equals 3. there was only one relative min. Maybe we'll go looking for relative maxes now. So, sorry, I guess I could just shrink this and make some room. Okay, what about relative maxes? So we need to see where the signs of the derivative are now changing from positive to negative. That happens here, and that happens here. So over here at -5, f has a relative max. And over here, right, f also has a relative max. Relative max, it looks like of f. So two places. And I don't need a separate justification for each piece. I can say them both at the same time. Not each piece, but each point, right? So I'm going to say f has a relative max at x equals what? -5 and x equals 7. Because what has to happen? Because f prime of x changes sign. How does it change sign? Changes sign from positive to negative at these values of x. This is so much fun. But, I mean, look, these reasons don't really change, ever. They're always the same. You're referring to the same theorem here, which is the first derivative test. So there's no reason, if I'm using the same theorem, that I would give different reasons. That would be silly. Okay, now, they did say max, min, or neither. Is there a place where the derivative was 0, but the signs do not change? Yeah, at -1. So this is neither here, a relative min or a relative max of f. And I have to say that, unfortunately. So I'm going to say and squeeze it in here. So f has neither a relative min nor, this is a lot of fun, a relative max, because at x equals, I got to say the x value, right? So at x equals -1, because f prime of x does not change sign. At x equals -1. So a lot of writing, and again, the importance of knowing your theorems, knowing your justifications, knowing how to put them together, and being able to provide a complete response, and doing that without having to write a page. There's no reason to write a page. That's a lot of writing for that question, but people tend to make it longer than it needs to be. Okay, so I think these are tricky to think. People are okay with A and B, then C starts to bother them a little bit. And then, something like D really starts to flip people out. So on what intervals is the graph of f concave upward? So you pause for a second and you're like, if I want to find like concavity, doesn't that come from the second derivative? And I'm like, yes, you are correct. And you're like, okay, well, I only have the graph of the first derivative. How would I be able to tell then something about the second derivative? And the answer is there's levels to this stuff. So when somebody says, oh, you want to tell me where f is concave upward, I think your mind immediately goes to, well, I need the second derivative to be positive, which is a good place for your mind to go. But the problem is, where is f double prime? I don't see it anywhere. It's not present on the graph. And I don't have a graph. I can't create a graph. I don't have a function to physically differentiate. What do I do? Well, this is the weird thing. While f double prime tells you about the concavity of f, it actually also tells you something about f prime. And this is sort of a little bit mind-blowing, I guess, but how would I be able to figure this out? I think we should maybe make this note here. When f prime of x is increasing, f double prime of x is positive. And you're like, what? Look, I know f prime is somebody's derivative already, but f prime is still in and of itself a function on its own right. We know that when any function, in this case f prime, is increasing, we know that its derivative must be positive. So how am I actually getting information about f double prime away from the graph of f prime? I'm looking at the slope of f prime, because the slope of f prime is its derivative, which is f double prime. So it turns out that when f prime is increasing, f double prime would be positive. Now, once you get that, it's okay, but it's hard to think about in the beginning. Also, I think the way we have to adjust our reasoning when we give our response for something like Part D really bothers people, and it takes some time to get used to. But where is this graph increasing, or where does it have a positive slope? So this piece and this piece. So actually only two pieces. The graph is decreasing everywhere else. So I'm going to state my intervals, and the intervals are those blue pieces where f prime is increasing, because if f prime is increasing, its derivative, f double prime, is definitely positive, because f double prime is the slope of f prime. So that's the relationship. It's the same relationship between f and f prime as f prime and f double prime. They're the same relationships. So I'm going to say that f is concave up on, now where are my intervals? So from here to here, so that's -3 to -1 union, okay, between 2 and then over to here, which is 5. We're like, okay, because. Now, I get that you want to just write this. You just want to say because f double prime is greater than 0 on these intervals. The problem with that is, where is f double prime anywhere on this page? I don't see it. And so when you provide justification to somebody, it needs to be based on something that was given to me or work I've done. I can't physically find f double prime in this situation. I can only infer information about f double prime by analyzing the graph of f prime. So in this situation, when I only have f prime in front of me, I really cannot say it's because f double prime of x is greater than 0, because then somebody's going to say, well, how did you know that? And the answer is to say instead, because f prime of x is increasing on these intervals. So technically speaking, to say that f prime is increasing is equivalent to saying that its derivative is positive. We know that from the last couple of weeks. But the reason I give cannot be what's in light blue. It needs to be about what's in front of your face, which is f prime. It's not f double prime. So it's pretty tricky. I think you have to change the way you're thinking about it. And, you know, there's levels to this, the meme, you know. Anyway, so on what intervals is the graph of f concave downward? Same thought process here as part D, but I think we should run that back because it's pretty, you know, it's a little, it hurts the mind a little bit. Somebody says f concave downward, you're like, yeah, I'm looking for f double prime of x being less than 0 or negative. Great, but once again, there is no f double prime here, and it's not something I'm going to be able to find. So I have to think about what that would mean in terms of f prime. And we know that if a function has a negative derivative, then that function has to be decreasing. Okay? In other words, right, the information that f prime tells you about f, it's the same information that f double prime tells you about f prime. One derivative backwards. Okay, so I'm looking now for where f prime of x is decreasing. So that's pretty easy to visually identify, right? It's this chunk, and this chunk. So now I got to state all those intervals and give a reason. So I'm going to say f is concave down on. So, where's that? -6 to -3 union, -1 over to +2 union, what, 5 to 8. Because, again, I'd love to just say because f double prime of x is less than 0, but however, that's not actually how you determine that from what is given to you. How I determine that is this reason, which is an equivalent reason, but it's sort of more concretely based in what we have in front of us. So because f prime of x is decreasing on these intervals. Okay, starting to feel a little bit better, but this can be a very taxing exercise to make these connections graphically. It definitely takes some practice. And the last major thing I could be asked for, and you probably would have guessed it because this is everything we've been doing the last 2 weeks, is, hey, what is the x-coordinate of each point of inflection on the graph of f? Justify your answer. Again, I come back to this thought process. It's like points of inflection. That was when like f double prime of x changes sign. And I actually don't even care which way it changes sign. The sign just needs to change. It's different from maxes and mins. There is no like maximum point of inflection or minimum point of inflection. It's just a point of inflection. So, but again, the problem is, in order to find this in terms of f double prime, I don't really have that in front of me. So I have to sort of translate f double prime of x changing signs to something about f prime. Now, this again is a little deep, but f double prime of x is the slope of f prime. So when would the slope change signs on the graph of f prime? Well, it would change, the slope would change signs when the graph changes direction. So f double prime of x changing sign is the same thing as saying f prime of x changes direction. It's pretty tricky. And so now I can look at the graph and say, where are the places that the graph changes direction? Now, you put on YouTube or something, and you're going to hear somebody say this very like esoteric, mystical statement, and I try not to think of things this way, but you might hear somebody say something like this: the turning points on f prime are the point of inflection on f. That is true. However, that is like a really high level thought that I don't think you really have initially. So I got to keep it simple. Where is f prime changing direction? I'm marking them off. These are the places where the slope of this graph would change sign, and so its derivative is changing sign. So there are 4 turning points on that graph: -3, -1, 2, and 5. So I'm going to say, finish this one off, thankfully, and move on to something else here. F has points of inflection at x equals, so I got to list them all out. That's fun. -3, -1, 2, and 5. Because, right, again, you would love to say f double prime of x changes sign, but that's not really how you were able to determine this from what you have. It's going to be because f prime of x changes direction. And I don't care which way it changes direction, because at some of these points, we see that the graph changes direction from decreasing to increasing. At some of those turning points, the graph is changing from increasing to decreasing. I don't really care. As long as that graph is changing direction and the second derivative is changing its sign, you have a point of inflection. So I usually tell students, like, when you're thinking about turning points and the first derivative test, you have to be way more specific about what you say. It's not enough to say the signs change. You have to be specific and say which way they change: positive to negative, negative to positive. If it's inflection, I just need a sign change to occur. So this one question does show you pretty much anything somebody could ask you if you were given the graph of f prime, the derivative of f. But obviously, we could change it up a bit, and somebody could give you the graph of f prime. F double prime. Now, that does change some things because it's definitely going to change how you interpret what you're looking at. But what I would also say is that there are less questions that can be asked if you have f double prime. You sort of lose some information every time you go down a derivative, but that's a story for another day. So 2, let f be defined on the closed interval from -3 to 3. The graph of f double prime, the second derivative of f, is shown in the diagram alongside. I might even write that out, nice big letters. Again, you have to take a moment here and say, what graph am I actually looking at? Because that really affects how you read and interpret what's happening on that graph. So A, on what open intervals is the graph of f concave downwards? Again, we're like, concave downwards, I need the second derivative to be negative. The good thing here, and this is different from number 1, is that here I'm actually looking at the second derivative. So I'm allowed to speak about the second derivative because it's in front of me. I don't need to go back and say, oh, it's where, f prime is decreasing. There is no f prime here. It's f double prime. So when would this function be negative if I'm looking at its graph? It would be negative when it's below the x-axis, which is just these 2 points. And this one is going to feel more like the reasons we're used to giving for concavity. So I'm going to say that f is concave down on, so that would be from -2 to -1, union 1 to 2, because f double prime of x is negative on these intervals. So that's my more typical justification I give. And again, I have the freedom to speak about f double prime here because I have the graph of f double prime in front of me, which is different than the previous question. B, on what open intervals is f prime increasing? Ooh, justify your answer. So again, maybe, we're back to there's levels to this, right? F prime of x is increasing. If this function, f prime of x, is increasing, its derivative would have to be positive. So who's the derivative of f prime? It's f double prime. So f double prime needs to be positive. So I do need to make, I have to interpret what I am reading, what I am being asked for. Very important. So if I'm looking at the graph of f double prime, where would its graph be positive? Well, where the graph is above the x-axis. So this piece in the middle, and then the right piece. So 3 different intervals. So I'm going to say f prime of x is increasing on, so that would be from -3 to -2, union -1 to 1, union 2 to 3, because f double prime of x is greater than 0 on these intervals. By the way, and I try not to talk about this stuff too early, but asking somebody where f prime is increasing is the same thing as asking when is f concave up. If that just blew your mind, just pretend I didn't say that. Okay, C, at what values of f does the graph of f have points of inflection? Justify your answer. We know that if you're thinking about inflection points on f, that the usual way we find those is we look for the places where f double prime of x changes sign. Now, again, because I'm looking at the graph of the second derivative, I have it in front of me, I should be able to see where the sign of f double prime changes. It actually happens 4 places: -2, -1, 1, and 2. So I'm going to have to list all of them, and this is pretty much my reason right here. So I'm going to say f has points of inflection at x equals -2, -1, 1, and 2, because f double prime of x changes sign. I don't care which way it changes sign. It changes sign for inflection. changes sign at these values of x. Again, please don't think I enjoy writing these reasons out every time. I don't. But that is the type of explanation that is expected to be given if you want to get full credit. There really is no other way around that. That's just how they're assessing. And again, I don't even think it's a terrible thing. It's important to be able to explain yourself. Okay, so, these types of questions with the graph, these definitely can show up in free response questions, but they can also show up in multiple choice questions, and I actually find those kind of tricky sometimes. So let's look through a couple of those as well. So the graph of f is shown in the figure above. Now that's different again, right? The first question, you had the graph of f prime. Second question, you had the graph of f double prime. This question, now you have the graph of f. So again, there's a lot of different ways to test somebody's knowledge on these ideas. So the graph of f is shown in the figure above. Which of the following could be the graph of the derivative of f? So now you're given f, and we're kind of saying like, hey, can I figure out which of these graphs could be the derivative of f? So I still have to think about what f prime would tell me about f. I know that f prime can tell me things like increasing, decreasing, and relative max mins, right? So I still have to think along those lines, but I sort of shift my thinking a little bit. So I don't know where I'm going to just make up a letter here, and I'm going to call it C because we have A and B, and C is next. I would say that if I look at this portion of the graph from A over to what I'm calling C, I would say that F is increasing on the interval from A over to C. And what that tells me is that on that interval, its derivative should be positive. And that would mean graphically above the x-axis. You see like the level of thought that happens here? It's taxing, but it is good for the mind. I will say that. So then I could say from C over to B, right? So maybe we should jot down some similar stuff over here. Let's get some of this junk out. So here, I would say that f, because I'm looking at the graph of f, right? The graph of f is definitely moving downward between C and B. So f is decreasing on the interval from C to B. So that's going to tell me that its derivative on that interval should be negative. And then graphically, that's telling me that the graph would be below the x-axis. A lot of thoughts happening. The other kind of key thing I see on the graph of f that's worth kind of bringing up here, maybe let's draw an arrow there, is this point. On f, this point is a high turning point. So it is a relative max, which means that, right, we should see on the graph of f prime that f prime of x, or really f prime of c, would be 0. So now look, this graph only goes increasing, then decreasing. That's all it does, right? So I should only see the graph change sign once. So I'm looking at these graphs, right? And, maybe it's the first one you check, maybe it's not but like, for example, let's look at C for graph C for a second. So you have A to B, and I'm assuming this would be like where C is. So from A to C, we're saying the derivative should be positive. On this graph, right, because these graphs all are potential graphs for f prime, right, here f prime of x is negative. That's wrong, okay? What's interesting about B is, right, maybe here is C, okay? If you look at B, the graph, and this again, I'm thinking, is this the graph of f prime? That graph is always essentially above the x-axis. That would mean that the derivative is always positive. But we know from our analysis on the graph above that sometimes the derivative is negative. So this is no good because f prime of x is always greater than, I guess we could write this, greater than or some places equal to 0, okay? Now, That's how I'm eliminating choices. I'm kind of looking for things that do not match my analysis that I did above. I think the answer is A, right? So let's assume here is C. So maybe we should use the same colors. That would be good. So here, right, from A to C, we have that f prime of x is greater than 0 above the x-axis. That checks out with my analysis there. From C over to B, okay, I would say that the graph is below the x-axis, so that tells me that f prime of x is less than 0. That matches with here. At C, the derivative is 0, and the signs change from plus to minus, right? So, like if I had a sign diagram here for this function for the derivative, the correct one at least, right? So you're going from A over to C over to B, right? Should be plus minus. So there should be a relative max here. And that's exactly what you have here. So it has to be graph A. If we check the other two graphs, there's definitely things wrong with it. Like, for example, if you look at D, right, this is, again, I'm thinking of this as being f prime. Here would be a relative max on f. Here would be a relative min. When I look at the graph of f up here, there is no relative min. So that's out. And you could do this kind of analysis eliminating each choice. The reason it's not E is because, right, this is a little harder to think about because E could be promising because it does what you want it to do in terms of signs and the way the signs change and all that. But this function is definitely not quadratic in nature. Quadratics don't have this type of behavior. The only way you could differentiate something and end up with a linear function is if the OG function was quadratic, which that is not. So it has to be, did I cross A out? I don't know why I crossed A out because I'm losing my mind. It is A. A matches all of the characteristics and analysis I did above. Okay, a few more. So now we're back to, and here's a nasty question. It's one of my favorites. So what do you got here? The graph of f prime, the derivative of the function f is shown in the figure above. Which of the following statements must be true? You have to systematically check these statements. There's no way that you could just like go, it's 2. That's not possible, right? You have to sit there and think about why it may or may not be true. The first one is a real piece of work, we'll say. F is continuous on the open interval from A to B, and you're like, whoa, wait a minute. We didn't ask those questions earlier. You're telling me I can ask even more different questions? Not much, a little bit. How, in God's name, would I know if F is continuous if I have F prime? Well, let's do each one of these with some notes. So I'm looking at F prime. One thing I could say about this graph in front of me is that it's continuous on the interval from A to B, right? This graph in front of me of f prime, it has no holes, it has no jumps, it has no vertical asymptotes. So if I look at the graph of f prime, I can see that f prime of x is continuous on the interval from A to B. Actually, you could even close it, right? We could include A and B. At A and B, there's not like, I don't have a hole there, so it's fine. We don't think about this too often, but if you're saying f prime is continuous, right? What that means is that its original function also has to be continuous, because f prime being continuous is the same thing. It's the same thing as saying that f is differentiable on A to B. That's a real, right? Like sometimes you ask people like, what does differentiability mean? It means that, right, its derivative is continuous. That's really what differentiability means. If you're a differentiable function, the function's derivative will be continuous. So we know because f prime is continuous, f is differentiable. But we also know that since f is differentiable on this interval, then f has to be continuous because differentiability implies continuity. I think that is a very tough question. The others are not so bad, but there's a very important life lesson we learn here with statements 2 and 3. So statement 2 says f is decreasing on the open interval from a to b. So in my mind, I'm like, f, right? F is decreasing. That would mean that f prime of x is less than 0, negative. So you look at this graph, and here's where some of the confusion comes in, right? Sometimes the graph is positive, so the derivative is positive. Sometimes the derivative is negative, so the derivative would be less than 0. You see, they're not saying is f sometimes decreasing on the interval from a to b. They're asking is f, and they don't say this because this is sort of implied, but is it always decreasing? And the answer is no, because sometimes the derivative is positive. So that means that f is sometimes increasing, right? So they're not going to say always. But if they say decreasing on the interval, they mean decreasing over the entire interval, which is a little deceptive, I think. But f is decreasing, f prime of x is less than 0. I would say this is false because sometimes on the interval from a to b, f prime of x is positive. So f is increasing some of the time, right? And, I'm being a little bit like kind of non-precise, like some of the time and things. But remember, in that multiple choice situation, so this is false. I don't necessarily need to be so prim and proper, but I definitely need to be able to think about things the right way. Okay, so 1 is true, 2 is false. What about 3? F is concave downward on the interval from A to B. So let's get off any annotations we made here. Okay, so and again, this would be always. Okay, but now there's levels to this, right? So you're like, F is concave downward, right? So I'm like, okay, that would be normally when f double prime of x is negative. However, right, like I don't have f double prime of x, so I have to think about it in terms of f prime. F double prime is the slope of f prime. So if I'm trying to figure out where f double prime of x is negative, that would be the same thing as saying when f prime is decreasing. And actually, if I look at this graph, it always is moving downward, right? F prime is always decreasing on A to B. That would tell me that f double prime of x is always negative on AB. So actually, statement 3 is true. So only statements 1 and 3 are true. So the answer is choice C. Statement 2 was false. And two more. I think we should do them. Obviously, you could skim through what you need anyway. Going back to a different multiple choice, and we keep switching up between like having the graph of f, having the graph of f prime, having the graph of f double prime. So in number 5, the graph of f double prime, the second derivative of f is shown above. Again, you got to have that, that moment where you're like, I am looking at f double prime. It's not f prime, it's not f. Because again, that really changes the way you interpret what you're looking at. So they're saying here is the graph of f prime, double prime, which could be the graph of f, the OG function. Well, what I would say to myself is, look, what information can f double prime provide me about f? If I think about it that way, I should be okay. So, and there's really only two things that f double prime tells you about f. It's concavity and inflection. So let's say this is obviously -1 over here. So I would say, and making notes here is not a bad idea, even jotting some stuff down when you're trying to figure this out on scratch paper, right? I would say that and I don't know where these are, right? Can we I don't know. I don't know if it's a good idea. I was going to say let's make up some numbers, but maybe we'll just color code it instead. I think making up numbers could be a little bit dangerous here. So on the red pieces of the graph, right? I'm saying, because I'm looking at f double prime, I'm saying on those intervals, f double prime of x is greater than 0. What that has to mean on those red intervals, that would have to mean that f is concave up on the red intervals. Okay, I can have a similar thought here about, let's say, we'll do green. I don't know why we're doing like Christmas colors here. Maybe because I want it to be winter break already. I don't know. Anyway, the green, let's switch colors. So on that interval, which again, I don't have numbers for, I would definitely say on the green piece that the second derivative is negative because its graph is below the x-axis. That tells me on that interval that f should be concave down. Okay, and then at these 2 points on the x-axis, we are seeing that because the graph of f prime is going from being above to below the x-axis or from below to above the x-axis, it must be that the second derivative at those points, at those x-intercepts, is changing sign. So I would say in blue here, f double prime of x is changing sign. And so since the sign is changing, right, f has, I'm just going to abbreviate, POI, person of interest. No, I'm kidding. Points of inflection at those 2 places. So we would have 2. There's 2 points of inflection. So from that analysis, and I get that having colors is helpful, but you could still do it without it. So I'm looking for the graph essentially to go from concave up to concave down to concave up. So I can eliminate choices pretty easily. Look, the first portion of this graph here, that's CCD. It's supposed to be CCU, concave up. That's done. Also in D, same thing, right? The graph starts off by being CCD, concave down. That's not what it's supposed to start by doing. It's supposed to be concave up. Okay, so that's out. And then you're left with C and D, and I think, or sorry, C and B, and I think one of them might have one too many changes in concavity, right? So let's look at B. B is, and now let's maybe use some colors. It is concave up for here to here, but then it changes to concave down here. So this would be your point of inflection. I guess I use green, right? Yeah. Wait a minute. That's not good. It's supposed to go from concave up to concave down, then to concave up. That did not happen here. It only wants CCU to CCD. This is out. It's got to be C, but let's make, yeah, C. Let's make sure. So, right, first it is concave up to here. That's that first point of inflection here. Then, right, in between, it's supposed to be concave down for a little bit. And that goes to about here where your next point of inflection occurs. Right? In here, in that little sliver, it's concave down. And then again, the graph becomes concave up. It must be choice C. Again, these are kind of fun if you're into this kind of thing, but it can definitely, tax the brain a little bit. Let's do one more and call it a day. So, number 6, the graph of the derivative of f is shown in the figure above. Once again, we're back to f prime now. We keep switching perspectives. Which of the following could be the graph of f? So you're looking at f prime, right? So, I mean, again, I have to say, okay, I'm looking for f. I have f prime. What is f prime going to tell me? Well, I mean, let's say this piece and this piece. So, and now we could actually probably use some intervals here. So maybe we'll do that, right? I would say that from negative infinity over to -2 and union 2 to infinity, I would say on those intervals that f prime of x is negative. So that would tell me that f is decreasing on those intervals. In between there, so that piece from -2 to 2, I would say that on the interval from -2 to +2, right, we can see that f prime of x is positive because it's above the x-axis. So that would tell me that f is increasing. Now, that might sometimes, right, that is enough analysis, and sometimes it's not. So there are a few other things I could lift out of here, right? So here and here, right? -2 and 2. And I haven't done this a lot, and I don't necessarily recommend it, but you could always, like, here's f prime, right? Like, you could just make the sign diagram and see some stuff, right? It goes like negative, positive, negative. And so at -2, right, the graph is going from decreasing to increasing. I think that's a relative min on f. And then at 2, the graph goes from increasing to decreasing. I think that's a relative max on f at x equals 2. So now I pretty much have everything I'm looking for. So I want the function to start by decreasing. And also I think, right, when you think about this, you have two turning points then, right? A low turning point and a high turning point. I don't think that A and B have any turning points on them. So I think those are immediately out. Okay, now, right, C, D, and, well, yeah, C, D, and E, they all look kind of similar, which is not great because then you start to get a headache. But I need the graph to start by decreasing, right? This graph starts by increasing. So that would be out, right? It's going up at first. I don't want that. And actually, so is this one. That one starts by increasing as well, right? So it's got to be E. And just to see with the colors and all, right? So first, it's decreasing. Check. Then it's increasing. Check. Then it's decreasing again. Check. Next thing, here at -2, there's a low turning point. That's a relative min. Well, check. Here, there's a high turning point, and that's a relative max. Well, check as well. So I'm just switching back and forth between the graphs of f prime, and f double prime, and I am asking questions based on graphical interpretation. Hope you're doing well. Talk to you soon.